Right now, I mean, at this very second, there is likely a $500,000 piece of cutting-edge AI
Yeah.
sitting completely useless on a data scientist's laptop somewhere.
Oh, absolutely.
And the math is flawless,
Yeah.
The predictive accuracy is just off the charts. But literally nobody in the company can actually use it.
Right. It is effectively just a highly sophisticated paperweight.
Yeah.
And the crazy thing is, it is happening in almost every major corporation today.
Well, welcome to the Deep Dive. Today, we are going on a mission for you, the listener. We're basically tearing down what we are calling the slide deck industrial complex.
I love that name.
Right, because we are taking a really hard look at the reality of corporate AI investments and specifically why so many of them fail to deliver any tangible return.
Yeah, the whole ROI myth.
Exactly. So the goal today is to help you fundamentally shift your mindset. We need to move from viewing data science as like academic research and start treating it as rigorous software engineering.
Because ultimately, if you are building data tools for a business, your goal should be delivering a URL, not a file format.
Not a slide deck.
Right, not a slide deck. And that transition from a file format to a URL, it sounds simple, but it represents a massive organizational chasm.
For sure.
I mean, we see an entire industry generating massive hype and honestly massive bills for projects that never actually see the light of day. They just kind of die quietly during the handoff.
Well, let's walk through how this actually plays out, because I think the standard scenario here is going to trigger some pretty intense recognition for a lot of people listening.
Oh, definitely. People are going to feel seen.
Yeah. So imagine a corporate data science team, right? They spend 3 months building a machine learning model. They spend hundreds of thousands of dollars.
A huge investment.
Massive.
Yeah.
And the validation scores they are getting in their little testing environment are just phenomenal.
Sure.
But then the final deliverable they present to leadership after all that time, all that money, is just a slide deck, a static PowerPoint presentation.
Which leads to what I genuinely think are the 3 most dangerous words any data scientist can say to leadership.
Oh, which are?
Basically, the model is ready.
Right, yeah. Which sounds like a total victory, like pop the champagne. But ready is doing a lot of heavy lifting in that sentence.
It really is. I mean, ready for what?
Exactly.
Because if we look at the actual mechanics behind that statement, the model isn't actually ready to be integrated into the business operations. It just lives in a code repository somewhere. Or, and this is very common actually, it is only running locally on that one specific data scientist's machine.
On their personal laptop.
Right. It relies entirely on their custom coding environment, their personal security credentials, and like a data pipeline they just duct tape together manually.
So the whole environment is basically custom tailored to one human being.
Yes, exactly.
So if a stakeholder actually needs an answer from this brilliant AI, they can't just log into a system and check it themselves.
No, they have to ping the data scientist.
Right, who then has to manually boot up their notebook, run the code, wait for the output.
It usually takes a while.
Yeah, and then send back a literal screenshot of the results in an email, like 2 days later.
And that 2-day delay, right, for an AI that is theoretically supposed to operate at the speed of light, that is the ultimate bottleneck.
It's like a master chef spending 3 months perfecting this revolutionary new recipe, right?
Okay, I like this.
And instead of actually letting the restaurant patrons taste the food, the chef just sends a beautiful photograph of the dish out to the dining room.
That is exactly it. The model has no surface. There is literally no interface for a user to interact with. So on paper, the project gets marked as delivered because, hey, the math was solved.
The box is checked.
Box is checked. The data science team moves on to the next shiny experiment, but the actual business gets zero operational value.
Okay, wait, let me play devil's advocate here for a second.
Great, so go ahead.
Because if these data scientists are brilliant enough to build these insanely complex neural networks and handle all this advanced statistical math,
They are.
right, why can't they just learn how to deploy the code themselves? I mean, why do we need an entirely separate engineering process just to get it off their laptop? Are we just creating unnecessary corporate bloat here?
It's a fair question, but it is a fundamentally different discipline.
How so?
Well, statistical math is about finding patterns in historical data. right? Software engineering is about building reliable, scalable systems that actually survive contact with the real world.
Okay, I see the distinction.
Yeah, so a data scientist is optimizing for accuracy. A software engineer is optimizing for stability, security, and scale. Asking a data scientist to build enterprise-grade cloud architecture is kind of like asking a brilliant architect to, pour the concrete and wire the electricity for the skyscraper they just designed.
Oh, that makes sense. So building a model in like a Jupyter notebook is basically like building a concept car out of clay.
Yes, exactly.
Like, it looks absolutely beautiful in the design studio. The theoretical aerodynamics are perfect. But production means taking that clay model and figuring out how to mass produce it out of steel.
Right.
You got to install a functioning engine, wire all the electronics, make sure it passes highway safety crash tests.
Yeah.
Because you cannot drive a clay car to the grocery store.
You really can't. That is a perfect way to visualize the engineering gap. Because taking a notebook to true production is rigorous.
It's actual engineering.
Exactly. It means ripping apart that monolithic, clunky notebook and writing modular code. It means establishing API contracts.
Actually, let's pause on API contracts for a second, because I feel like that term gets thrown around a lot in meetings, but the actual mechanics of why it matters are super crucial here.
Oh, absolutely. It's foundational.
Right, so think of an API contract like a restaurant menu. The software engineers, the people building the user interface, they are the customers. They don't need to know how the data scientist, who is acting as the chef in this scenario, is cooking the meal back in the kitchen.
Yeah.
They don't need to know the complex math.
No, they really don't care about the math.
They just need a guaranteed menu that says, if I send you a customer ID number, you promise to hand me back a churn probability score.
Right.
And that contract allows both of those teams to work completely independently without, breaking the whole system.
That's spot on. And without that contract, every minor tweak the data scientist makes to the model back in the kitchen could just crash the entire application for the end user.
Wow.
Yeah. And true production also requires robust authentication protocols, so only authorized users can actually trigger these predictions, right?
Which is huge for security.
Exactly. It requires cloud infrastructure that can handle, say, 10,000 requests a minute without crashing. And crucially, and this is where a lot of teams fail, it needs active monitoring systems looking for data drift.
Yes, data drift. That is fascinating because it really highlights how fragile these models actually are in the wild.
Oh, incredibly fragile.
Because a machine learning model is trained on a snapshot of the past.
Right.
Like, let's say you build a model to predict consumer spending habits based entirely on data from 2019.
Okay, pre-pandemic.
Right. And it might be 99% accurate in your testing environment. But then a massive global macroeconomic event happens in 2020. Suddenly, consumer behavior fundamentally changes. The whole world shifted, but the model didn't.
Right. So the model will happily continue making highly confident, completely incorrect predictions based on an outdated reality.
It has no idea the world changed.
Exactly. That is data drift. Real software engineering builds retraining pipelines that monitor the incoming real-world data, detect when those patterns start to shift, and automatically trigger the model to update itself.
That sounds complicated.
It is. Building that automated self-healing system takes an immense amount of architectural skill.
Which I think brings us to a major billing reality check.
Oh boy, the billing rant.
We have to talk about it.
Yeah.
Because moving from a theoretical notebook to a hardened, self-healing production system requires days, sometimes literally weeks, of focused engineering.
Yes.
Not hours of enthusiasm.
I love that phrase. Hours of enthusiasm.
Right. But there are so many consulting firms and even internal data teams that will happily bill a company for endless hours of enthusiasm.
Oh, it happens all the time.
They will spend weeks tweaking algorithms, doing pure academic research just to get a 0.1% bump in theoretical accuracy. But they completely lack the software engineering chops to ship a single API.
It's a massive misalignment of incentives. The focus and honestly the funding are almost entirely skewed toward the model itself, the math, the shiny algorithm.
Yeah.
But enterprise AI almost never fails at the math. It fails at the handoff. Taking the project from an isolated experiment to a living, breathing software system, that is the single most critical moment.
The bridge between the two.
Yes. Yet most organizations simply do not have a dedicated role to own that specific journey.
Everyone just assumes someone else is doing it.
Exactly. The data scientist assumes the software engineer will handle deployment. The software engineer assumes the data scientist built something that's actually deployable. And the business leader is just sitting there waiting for a tool they can actually use.
And because the model is trapped in this organizational void, the only thing the data scientist can give the business leader is
A slide deck.
a slide deck. And that reliance on static reports creates a massive psychological barrier for leadership, which really brings us to the trust deficit.
Yeah, the trust deficit is huge because human beings have a very specific way of interacting with information, especially when there are millions of dollars on the line.
Right. You aren't going to just blindly trust a computer.
No, stakeholders simply do not trust what they cannot interact with.
Put yourself in the shoes of, like, a vice president who needs to decide where to allocate a $10 million marketing budget.
Okay, high stakes.
Very high stakes. Someone slides a beautifully formatted PowerPoint chart across the conference table showing a machine learning prediction. As an executive, I'm looking at that chart as your curated interpretation.
Exactly. It's static.
It's been polished. I can't poke at the underlying assumptions. I can't ask it what-if questions like, if I drop the marketing spend in the Northeast region by 10%, what happens?
The chart can't tell you.
It literally can't.
So it feels like someone else's reality. The VP basically has to blindly trust the invisible math done by a data scientist they rarely even speak to.
And that lack of interactivity just breeds deep skepticism.
Absolutely. If a business leader cannot touch the mechanism, they will inherently doubt the output. Every time.
But handing someone a live URL instead of a static slide deck changes that entire psychological dynamic instantly.
It's night and day.
Because a URL is an interactive reality check.
Yes. When a business leader can open a user interface on their own browser, input their own assumptions, adjust their own regional data, and instantly watch the prediction update, that builds visceral, immediate trust.
They can feel it working.
Right. They are no longer looking at an interpretation. They are test driving a capability.
And there is a very specific shift in the dialogue that happens the exact moment you move from a file format to a URL.
Oh, I've seen this happen.
When you are operating in the slide deck industrial complex, the question from leadership is always, can you run this scenario for me?
Which just creates more manual work.
Exactly.
Yeah.
The data scientist has to go back, rerun the notebook, wait 2 days, and create another deck. It's a service request. But the second you hand that leader a URL, the conversation immediately shifts to, how do we scale this across the entire department?
Right, because they stop asking for a favor and they start looking at it as a lever. That tangible interaction, that moment where the decision maker can touch the tool and see it function in real time, is the exact moment a project secures funding for the next quarter.
Because it moves from being an R&D expense to an actual operational asset.
Exactly.
So let's take all of this theory we've been talking about, right?
Mm-hmm.
The notebook bottleneck, the engineering gap, the psychology of the URL. Let's drop all of that into a hyper-competitive, high-stakes environment.
Okay, let's do it.
Let's look at the consumer packaged goods industry, or CPG.
Oh, CPG is the perfect crucible for testing this product-first mindset because of the sheer volume, velocity, and fragmentation of the data these companies deal with every single day.
So picture a massive global brand that sells, I don't know, laundry detergent or snack foods.
Right.
They're sitting on absolute mountains of disconnected data. They have point-of-sale data streaming in from 50 different supermarket chains.
Non-stop.
Non-stop. They have media spend data coming from their advertising agencies. They have internal store performance metrics, complex product mix data, supply chain execution logs, and just endless streams of consumer behavior signals.
It's overwhelming.
The data already exists. They have more data than any human could possibly read in a lifetime. What is missing is the decision.
And that missing decision is agonizing for leadership because of how that data is stored.
It's all siloed.
Completely isolated silos. The sales department has a dashboard tracking retail execution. The marketing team has a vendor report sitting in an inbox somewhere detailing media performance. The supply chain team has a predictive model locked on a local shared drive. And the overarching strategy, well, that lives in a classic PowerPoint deck that only gets updated once a quarter.
The absolute absurdity of the corporate expectation here is staggering to me.
It's wild.
You have all these disconnected, highly complex silos, but leadership expects some mid-level manager to manually pull the data from the dashboard, read the vendor report, ask the data scientist for a screenshot of the local model, synthesize millions of data points in Excel, and have a comprehensive, optimized market strategy ready by Friday.
Oh, Friday afternoon, right.
It's a mathematical impossibility.
It is completely impossible if you are relying on manual analysis and slide decks. In an environment that fast, shifting from presenting results to shipping a product literally becomes a survival
You
imperative.
have to adapt.
Exactly. Consider a pattern-breaking approach to this exact problem within a large CPG company.
Yeah,
Notice what the mandate of the project was not. The goal was not to build another dashboard for someone to check.
right.
It was not to create a better slide deck. And crucially, it was not to run an isolated AI experiment just to prove the data science team knew how to use the latest shiny algorithm.
The actual goal was to turn all those fragmented signals into a single, unified decision-making capability.
Yes, a living system. What made the project valuable wasn't the machine learning model itself. The model was just, one gear inside a much larger machine.
Just a piece of the puzzle.
Exactly. The real value was the software engineering built around that model. The engineering team built pipelines that connected the point-of-sale market signals, the retail execution performance, the demand forecasting patterns, and the company's financial constraints, all into one automated environment.
Going back to our URL versus deck conversation, they didn't hand the VP of Sales a research report.
No, they didn't.
They built a secure, web-based tool. They gave them a product that answers the actual questions, keeping them up at night.
Right.
A leader could log in and instantly see, where is the real market upside right now this week? Which specific regional stores are underperforming relative to the forecasted demand?
And is our heavy television media spend actually driving incremental sales at the register, or are we just wasting money?
Yeah, exactly. Where should we put our next dollar of activation to maximize return?
Because in CPG, speed is the ultimate advantage. The industry moves far too fast for a quarterly strategy deck to be relevant.
A quarter is an eternity.
It really is. Consumer trends shift in days. Supply chains bottleneck in hours. The team that can spot a micro-opportunity in the market, measure what is actually working in real time, and dynamically redirect their resources faster than the competition. Well, that is the team that wins the quarter.
And the company that successfully builds these integrated decision systems, the ones who actually invest in the engineering to get the AI off the laptop and into a URL, they're going to operate at a completely different velocity.
Absolutely.
They will run circles around the dinosaur companies, still relying on manual Excel analysis and a 50-page PowerPoint deck that took 3 weeks to assemble.
The future of enterprise AI requires a total migration away from fragmented analytics. We just have to move toward integrated decision systems.
From static reporting to continuous detection.
Exactly. From static point-in-time reporting to continuous automated opportunity detection. You have to abandon the comfort of isolated insights and actually do the hard work of building capabilities that guide execution at scale.
Well, we have covered a lot of ground here today, dismantling the slide deck industrial complex from the local laptop trap all the way up to a global CPG decision engine.
We really have.
Let's synthesize the core lesson of this deep dive for you, the listener. The mandate here is loud and clear. Stop presenting results and start shipping the product. The era of treating data science purely as academic research just has to end.
It really does. And to make this actionable for you, think about your own organization today. Look around your department. What is one crucial signal in your business? Maybe it's a piece of customer behavior or supply chain data or a financial metric that absolutely should already be connected to your daily decision-making, but isn't.
And be brutally honest with yourself about this next one. Look back at the last major AI or data project at your company that just quietly faded away.
We all have one.
Right. What truly killed it? Was it really a failure of the machine learning model's math? Or was it a failure of the handoff?
9 times out of 10, it's the handoff.
Did it die because nobody built the bridge from the data scientist's laptop to the business user? Did it die in a slide deck?
Because recognizing the handoff as the primary point of failure is really the first step toward building something that actually survives contact with reality.
We started this deep dive talking about physical engineering, about how a bridge either lets cars cross the river or it doesn't.
Right.
So I want to leave you with a final lingering thought to mull over. If brilliant data science, without the rigorous software engineering required to back it up, is ultimately just a very expensive paperweight, at what point do we as an industry need to fundamentally flip our valuation?
That's a great question.
At what point do we start paying more for and prioritizing the unglamorous plumbing, the API contracts, the user interfaces, the data drift monitoring systems than we do for the shiny algorithms themselves? Until next time, keep digging.